Section 5.7, the sum of angles measures in polygons. We start with hopefully the simplest one, the triangle sum theorem. In a triangle, there are 180 degrees. So if I start with a right triangle, of course, that one's 90 degrees. And if this angle over here is, say, 40 degrees, this angle has to be 50 degrees. So we know that in any triangle, we're going to get 180 degrees. There's several different ways to look at it, but just for simplicity, we'll just start with that. In a quadrilateral, there's 360 degrees. And we can think of that in terms of like a rectangle. We have 4 90 degrees angles, or 4 right angles. So 90 times 4 is 360 degrees. So anytime you have a convex quadrilateral, no matter what it looks like, trapezoid, whatever, the angles are going to add up to 360 degrees. As we get larger, we go back to the idea of the triangle, and we do what we call a triangulate it. So if I go with a pentagon, if I start with one point, and I draw in the diagonals, I have 3 triangles. Each triangle is 180 degrees. So 3 times 180 degrees, because there's 3 triangles, gives me 540 degrees. If I go to a hexagon, 1, 2, 3 diagonals, which gives me 1, 2, 3, 4 triangles. So it's 4 times 180 degrees is going to be what all of those angles are going to add up to. And so on. So this figure's got, I don't even know how many sides, 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's an octagon. 1, 2. So it's 1, 2, 3, 4, 5, 6 triangles. 6 times 180 is what all of the angles will add up to inside of that. So it keeps getting larger and larger and larger based on the number of triangles that you can create. And that gives us a formula. And the formula is simply n being the number of sides of your convex polygon. So you take n and then you subtract 2 times 180. And you subtract 2 because n minus 2 is the number of triangles you can create. Number of triangles. If I back up a second. So here we have 5 sides. So n equals 5, and there are 3 triangles. Here n equals 6, and there are 4 triangles. Here n equals 8, and there are 6 triangles. Sorry for my bad 8 there. There's always 2 fewer triangles than there are sides. So that's the first kind of problem that you're going to need to be able to do, is to figure out the sum of all of the angle measures. There's also the idea of an extended ratio problem. If we have an extended ratio of 3 to 5 to 7, here's how we're going to solve that. We're going to put an x with each one of those. 3x plus 5x plus 7x, and we're adding them all together. What do all the angles in a triangle add up to? 180. So now we're just going to solve that. So that's 15x equals 180 degrees. We want to go ahead and divide by the 15. And x is equal to, what is that, 12? So x equals 12. So then the measure of the angles, one angle would be 3 times 12, or 36 degrees. The next angle is 5 times 12, which is 60 degrees. And the last one is 7 times 12, which is 84 degrees. And if we add those all up, we should get our 180. So an extended ratio, you're just going to go 3x plus 5x plus 7x, or whatever the numbers happen to be. That's kind of a quick version on that. Hopefully that helps a little bit as you're working on those.